Did I say I was going to give it back to him, or was he going to get it himself? We'll find out. Some of the students won't show up today. They'll be fine. Sorry. So let me get, where are we at? What do I look at here to see what makes it? Yeah. So you say the bottom. Now the way it's worded, you could say this, and that's fine. But in general, I say I don't want the bottom to be 0, right? Does that make sense? The bottom can't be 0 is how that looks like in English. The bottom can't be 0. And then if I solve this, I get the x can't be 1. Bam.
You could put it.
Or yeah, if you have x equals 1, that's fine. You're answering the question. X equals 1 would make it undefined. I just like this a little better because it's more direct, saying x can't be 1. So what do I look at here? X plus 7 can't be 0, so then x can't be negative 7. And here, I just have to do what first? Factor. So you get
X minus 4.
X plus 4.
I like it. I heard you backwards. So you get x can't be 4 or negative 4. So effectively, when I write it like this, I am saying x can be everything else. Yes, ma'am.
For B and C, or for B at least, I've also noticed that x can't even be 0 either.
What happens if x is 0?
The way when I plugged it in, it didn't work out.
Well, if you plug 0 in, you get 2 minus 0 over 0 plus 7. You get 2 7s. That's fine. So the only things you have to exclude are any values that make the bottom 0. And if I plug a 0 in for x, I get 7 on the bottom. That's okay. It's only if I cancel that 7 out, it becomes 0. So it can't be negative 7. It can't be the opposite of 7. So this one can't be the opposite of negative 1. So that's why it can't be 1. Do you see that?
Yeah.
It's a little different way to say it. So this one, it can't be the opposite of negative 4 or 4. So it can't be negative 4 or negative 4. But this one, there's a few different ways to look at this. But no matter what you pick for x, the bottom is 7. So we just answered the question. What value of x makes the bottom 0? No matter what x is, the bottom is 7. Now, if you understand that statement, you must understand the answer. What value of x makes the bottom 0? None. No matter what you make x, the bottom is 7. Do you guys get that? Yeah, or the question is, what values of x make the bottom undefined? None, or no values, or however you want to say. Don't say no solution, really, because it's not really an equation.
Because the question says what makes the bottom 0. So
Yes, exactly. So no values make it 0. Or none. None's a little grammatically incorrect, but I know what you mean. I'm never going to claim my grammar is great either. Well, like if grammar disturbs me. Okay, alright, so how is that first value? I want to throw that in there just to let you know. I mean, there's not always going to be a value of x. If I had put this, 3 over x squared plus 4, same answer. What do you square to make negative 4? What real number do you square, in case some of you guys know about imaginary numbers? There's none. There's no real number squared to make negative 4. That's the only way you can make it 0. So that would have no values of x, make it undefined. Now, real quick. If I ask you what's the domain, and we haven't officially talked about domain, then you would say the domain is all real numbers. Because the domain is what values are you allowed to use. So my question is, what values can you not use? None. So what values can you use? All of them. I like it. So for some of you guys that are saying all real numbers, I understand where you're coming from. That's if they ask you what's the domain of this. Okay, stop there for a second. Okay, stop. Okay, so what about, so if we could do 2b, 2a is like, nice. You just got to remember how to do the top one. Since that's a 2, what do you got to do?
2 times 15.
So you get negative 30.
3
and
10.
Negative 10. So I can rewrite the top as 2a squared. Now I would put minus 10a plus 3a minus 15. Now real quick, just Let me come back to that in a second. I just want to make sure you guys sort of understand the motivation. So if I have 2a squared minus 7a minus 15, couldn't I rewrite that as 2a squared minus 3a minus 4a minus 15? Are those different?
No.
Aren't they both the same thing?
Yeah.
But if I try to group this, it won't work. So the only way to break negative 7 up into two parts is to do this process. If you can get the numbers that make this process work, that's the way to rewrite it to make the grouping work. That's the whole idea of this. If I can make those 3 terms become 4, I can group. And grouping is easy. I have no problem just saying that it's easy. It just has to be easy. Right? So now that I've rewritten this in this form, now the bottom should be also, the bottom should be easy. If I just take the 4 away, you guys can probably do that. The 4 throws us off sometimes. So you just cut that in half also.
2a plus 3.
Good. 2a plus 3.
2a minus 3.
So in the top, what comes out of these two?
2a.
2a.
A minus 5.
A minus 5. What comes out of these two?
3.
3. Thank God the same thing, right? So finishing up the top here, what do you get?
2a plus 3.
Yeah, 2a plus 3.
A minus 5.
A minus 5. So what cancels?
2 plus 3.
Plus 3.
Bam! So you end up with that. You end up with... Sorry. That's what it looks like I've written. A minus 5 over 2a minus 3. Got an F in penmanship. I probably need F minus. Alright, how are we doing so far, Zach? So again, this is the whole thing is the more you know factoring, the easier all of chapter 7 is. Alright. So this one, what about part C? Why is part C relatively easy? They already have LCD. So I just have to combine the tops. Negative W plus W is 0. 4 plus 4 is 8. So I get A over 12, which is become a 3 there. So they already have the LCD, thank God. I just got to slap my like terms together on the top. So part D, the same idea, just a little bit. You remember that minus in the middle. You got to stop your brain and say, brain, hold on, we got to be careful. So I got x plus 5. They already have LCD, so I can just slap these together. Minus 3 plus 2x. I like it. So you must, I'm not picking on anybody. In fact, I'll do something different. You can't make that 1 over 2. Because they are part of addition problems, are they not?
Yeah.
And division cannot break into an addition problem. It's not that powerful. It can only mess with multiplication. Alright, so if I can rewrite one of those as multiplication, then maybe something will cancel. Of course, which one can you do?
The denominator.
Denominator. What do you get?
2. 3x.
Now, this is something over 2 times the same thing. Division can kill that multiplication bond. If you want to make it look more like chemistry, but let's not do that. Bam! So it's the answer 2. Yay!
No.
No, good. 1 over 2, because the answer 2 is on the bottom. Kick ass. So then I was a little evil, and I put a problem from section 7.4 on here, just to see what you guys would do. That's nice, Jeff. And just to remind you guys, here's the example I was given a few of you. If I had this, how do I do that? Yeah, because what's 15? 3 times 5. So he's already got a 3, so what's he need? A 5, right? And then blah, 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 blah. That's it. So here, do I know what this has in it? Not yet. What does it have in it? So what do they both already have? The x plus 8. So what is this guy missing?
X plus X negative 2.
X minus 2. it's almost too nice to believe that it's true, that you can do it this way. You factor it, and then you say, who's missing something? Always, the joke for me is always, it's like having kids, and the one kid, he got sprinkles on his ice cream. Okay, here's some sprinkles. He's got more ice cream. Okay, here's more, and then I just eat it all. But here you're just giving the one that's missing something what they're missing, right? To appease the kids. So this guy was missing an x minus 2, so he gave it to him. Now they both have this on the bottom. So then you can combine them. So it'll be 2 plus
5x.
5x
Negative 10.
minus 10.
How much is plus?
Let me stop there for a second. Let me finish this out, and then I'll go back and show you the biggest mistake people make. So one more step, really, and we're done.
Subtract.
5x minus 8 over x plus 8, x minus 2. That won't factor, so you know you're done. Nothing else can cancel. So the big mistake people make is, off of this step, they do this. Can you see that? There. Do you see how they just write 2 plus that over x plus 8, x minus 2, and then what do you think they do? Cancel those. And some of you guys are like, well, that I know because I did that. Why can't you not do that? Part of an addition problem. Oh shit. Division cannot break into an addition problem. It can't do that. That's why I wouldn't even write this. I would distribute the 5 and then put that down there and then get my like terms together. That's how I would do it. So I'm not even tempted to kill that. We're all human. We want to have less shit to have to work with. I can't blame you for wanting it to die. Right? But it just don't. Zombie problem. Alright. Is everybody cool with that? And then finally, who has the key on the bonus? They each... What can you do? This would so suck to say, well, this guy is missing an x minus 5 and x, but oh my god, that would so suck. What can you do with each of these?
Factor.
Yeah. So this would be x minus 5,
X plus 4.
x plus 4. So the x minus 5 cancels. This would be
GCF.
4x plus 3 over x plus 3. So the x plus 3's cancel. This would be x times x minus 7 over x minus 7. So the x minus 7's cancels. So you end up with x plus 4 minus 4 plus x.
Cancel.
2x. Okay, so several of you guys got that kick-ass. I like it. So, dear God, if you saw 12 over 6 minus 72 over 8, I hope that none of you would get LCDs. Holy shit. 12 divided by 6 is... 12 divided by 6 is 2. 72 divided by 8 is 9. Right? I mean, you reduce a fraction wherever you can. Of course you do. Before you start doing anything. Here, they reduced so far they became whole numbers. Yes! That's my point with this. You don't start giving them LCDs. You first see, will any of them reduce, so I don't even have bottoms to worry about. They all did. Holy shit. Okay. That was bonus, though. So if you didn't see that, don't freak out. So any questions about any of those problems? Okay, so let's do this. Let's take a break. And then when we come back, we'll do the word problem handout. And then we'll see what time it is. So come back 15 after. That's perfect. 15 after. Somebody hit the lights so nobody goes tripping. Can somebody turn the lights back on? No. There won't be a 0 in the quiz. Whatever grade you make on the test, I will also put in. Okay, fine. But you can have a copy of it so you can see what.
I'm about to leave the room and I'll redo it. Can I take one of the extra ones to 7 so that she can look over anything? Sure. Yeah. I know she can't turn it in, but I like to turn it on.
Yeah.
That's what was throwing me off. I converted it to the
Actually, there is formula for Q.